used to identify risks. Before to the tool itself, I want to give you a bit of background on IPIECA itself. IPIECA is the Oil and Gas Industry Association for Environmental and Social Issues. It was 1974 following the launch of UNEP. It is the industry's principal channel of communication into the United Nations. It's a global oil and gas association involving both the upstream and the downstream part of the oil and gas industry. Membership within IPIECA covers over half the world's oil production. And see on this slide that you can view, IPIECA has helped the oil and gas industry improve its environmental and social performance through methods including the development and promotion of good practices and solutions, enhanced communications, and only trying to give the industry tools in order to execute this. And the presentation you'll see today on the Global Water Tool is an example of how IPIECA does try and put together these tools to help. The aim of this webinar is to promote and encourage the take of the IPIECA Global Water Tool for oil and gas. In order to demonstrate that, we thought it would be best to take a hypothetical company, in this case, the U.S. Energy Company, and to illustrate how we apply the Global Water Tool to gain a global risk perspective, and look at the compatibility with that Global Water Tool with local water tool, and they're interconnected. To present this today, Jill is a Vice President at CH2M Hill, and has really helped develop this and other tools in the water industry. If you have any questions, please use the Q&A box off to the right-hand side, and we'll hold all those questions or group those questions until the end of the presentation to allow 15 minutes there to answer those questions. If you're looking at the tool itself and interested in looking at it, you may download the tool at the address shown on the screen here, and more information at the end of the presentation to help you download or answer questions. With me, turn it over to Jandel to present to you the Global Water Tool for oil and gas.
Thanks, Carl. Hi, everybody. I see I have some people probably on the other side of the time zone, so happy Friday to some people. We're still here on Thursday in California. But hola, ni hao, buongiorno, and welcome to everybody that's on the call. Today we're going to talk about using this tool as if a real company was using it, but U.S. Energy is actually a fictitious entity with no relation to an actual company. I actually planned to use Universal Energy Company, but it turns out one of those actually exists. So today we're going to imagine that there's a Universal Energy Company in the world, and they need to develop and execute a water management plan, and they're going to use the Global Water Tool and the Local Water Tool to help them do that. We're going to cover an overview of the Universal Energy Company, in this case for why they want to manage water, their water policy and performance goals, their concerns, how they go about getting the global perspective through the use of the Global Water Tool, do site risk management through use of the new Local Water Tool, and how they view continuous improvement looking forward. A bit about the Universal Energy Company. It is based here in Laguna Beach, California, not too far from Disneyland, so it's a good place to imagine an imaginary oil company. It's an integrated energy company. It has exploration and drilling, production, gas processing, refineries, and petrochemical, and it operates and plans projects in 7 countries. It does not oil sands or retail. The business case for water management for Universal Energy is shown on this slide. Fresh water is already a scarce resource in many parts of the world, and scarcity is projected to increase in many places due to population increase, industrialization, and climate change. Universal Energy faces many water risks, including environmental risks with impacts to regional ecosystems, social risks, competitions for the resource, health, fresh and sanitation for employees in the countries in the world that don't have sustainable water supply and sanitation, regulatory risks, resource risks around availability and quality, and regional risks from stakeholders and local communities. There's Energy Company is focusing on incorporating freshwater management into strategic oil and gas processes because they view them as an integral part of their social and environmental responsibility, managing water-related business risks, improving operational efficiency. Energy's water strategy and public commitments are on this slide. The objective of our water strategy is to optimize how the company manages water, and we're committed to conserving, protecting, measuring, and monitoring all our water usage. We want to optimize expenses and minimize risks by focusing on water assessments on assets that have the greatest impact. And we're working to identify and develop best practices at the local level and then apply that knowledge across all assets. And we wish to utilize the company's research and development resources to drive technology advances. We've met and spoken with stakeholders, and these are their three top concerns around water. First and foremost, they want us to do no harm. They want no environmental impacts from operational discharges. They want us to minimize our freshwater use in areas of stress so that fresh water is left for people and for ecosystems. They want no environmental impacts from water use. So we started down of water management at our company by looking at the global perspective, because we are a global company with about 35 sites around the world and in 7 countries, and we thought we needed a global perspective on where our risks and impacts are and whether we were managing those risks and impacts well. So we decided to our operational portfolio for 2 key reasons. One, for external communications. We knew we needed key quantified metrics that could establish our credibility with stakeholders around our water management. Because if you don't have strong metrics to report to stakeholders, how can they believe that you're truly managing water? Because at basic level, if you treasure it, you'll measure it, and to measure it, you have to measure it. So it's very important that we have key quantified metrics that we can share with stakeholders. And then there was a lot of internal purposes for doing this global perspective and looking at quantified metrics across our operations. First and foremost was communication. We needed to be able to communicate real numbers about the role of water in our operations to upper management and across the different business units. We knew we needed better water information management. We had a credibility issue and gaps in our environmental management information system, and we needed a better approach to take care of that. We wanted to manage risks. By looking at our sites around the world, we wanted to take them in terms of risk, in terms of how much fresh water was used at each site and what the external risks were around water availability. We wanted to benchmark. I wanted to look at the water intensity per unit of production from sites and similar sites, get recycle rates. Why? To see if there were good practices that we could promote technology transfer on across business units. So we, the IPIECA, went and downloaded the Global Water Tool. And you could do that right now. You could multitask while I'm talking and actually do that. All you have to do, the long URL, but you can just search on IPIECA and Global Water Tool and you'll be taken to the website. And what you'll find is an Excel file that you download to the privacy of your own computer and out. So how to use it, got on the website that step-by-step explains how to use the tool and some other supporting information so that you're able to use the tool yourself. A bit of history. Back in 2007, we actually launched the General Global Water Tool with World Business Council for Sustainable Development that was aimed at all companies. But there was an interest from oil and gas companies to customize it specifically for your industry. And that last year we worked with IPIECA and quite a group of oil companies to create this customized version just for oil and gas. And it includes things like produced water and reinjection for production and so on, customized from the original general version. But the good news is that all the trial and error and testing that we'd done over the years on the general version was included in this customized version, so it operates quite well. So the first thing you do is download this Excel worksheet onto your computer, look at the How to Use It guide, and then open it up and get going. And the first step is to enter your site names. As you can see on this slide, the first column is site names and location. Now, there's a function in there where you could just enter the address, and there's a search button for latitude and longitude, but we really encourage you to really make sure those latitude and longitudes are correct, because later we're going to link to external databases with those lat longs, and we really need to make sure that they're correct. So you can either search and use them through the tool itself, or you can find those lat longs on something like Google Maps and enter them yourself. So the first step is to put the names of all your operations and their locations. Now, if you have water data, that next step is to enter it into this inventory sheet. And you can't see the whole spreadsheet in the slide I'm showing, but it's quite a wide horizontal spreadsheet that essentially guides you in an inventory of entering your water sources and volumes and names and your water discharges. Important to put what data you have in there, and then the tool will actually help you do a data gaps and credibility analysis, which I'll show you on the next slide. We did for the Universe Energy Company, and we looked at the water inventory sheet and did a review of the operations and could see some errors. We knew that there was a missing amount of water withdrawal for the onshore New Mexico site, and also when we looked at the water discharge site in the onshore China facility, we knew that was wrong because there was no freshwater discharge at that site. So we spent some time with our business units and went and got corrected data and filled in the blanks and finally got a full data set in the next slide. This is what the full inventory will look like once done. This is your inventory sheet that shows for each site the water withdrawal, water discharge, and water consumption numbers that are calculated. Next step is then, once you're got your Excel file open on your computer and you're connected to the internet, is to press a button, which is within the tool on the home page, and you're connected to the World Business Council for Sustainable Development's website.
During the conference.
On that website, we have about 15 maps and background databases that your sites are to. And this is, by the way, this is all anonymous. No one knows that your company's linking or doing any of this, and none of your data is collected. But basically, by pressing this button and connecting to the data sets and maps that are connected on the server, you can see the global portfolio of your operation in relation to these maps that we have saved, and also automatically downloads data into your into spreadsheet for doing distribution analysis later on. So the first step then is to click and link to the World Business Council server and see your maps. And it's important at the very first stage to make sure that all the sites are in the right place. Actually, for this example, you can see on the screen some of our production facilities were offshore Philippines, and we knew this wasn't right. So we went back and took the time to correct lat longs and ensure that all of our sites were actually in the right place. Now, once you've done that, all the hard work is done, and you get to start looking at all of the analysis. These are the country maps that are on the World Business Council server, and once you've entered your information and connected to the server, you can see all of your sites plotted on these maps. We have renewable water per person in 2008 and projections to 2025 and 2050, and those are data sets provided by the Food and Agricultural Organization. Also, water withdrawal per person, industrial water withdrawal as a percentage of total. Dependency ratio, which is really important for countries that are that have to rely on water from other countries in order to have renewable water sources. And we've got the health and sanitation maps from the World Health Organization and UNICEF of populations served with improved water and populations served with improved sanitation. Maps I'm showing you are the watershed maps, and these are really the best maps to use in terms of looking at external water data because they're more granular. They're not just at an average country level, but they actually look at the watershed level and provide specific data at that level. And the map we've got are the annual renewable water supply per person for 1995 from World Resources Institute, and also that projection to 2025. From IWMI, we have the Environmental Water Scarcity Index, Green Annual Relative Water Stress Index, and we have the Physical and Economic Water Scarcity Index, and we've actually added the Biodiversity Hotspots map from Conservation International. It allows you to see if any of your sites are in these areas of hotspots or not. So you can press the button and plot all your sites on these maps, and you can easily print and save the maps with a variety of functions, either by screen save or by the print function, and download your sites on these maps for use in your own reports or in internal communications. Now, you heard that one of the key reasons we wanted to do this portfolio assessment was to look at the role of water in operations and be able to communicate key messages both internally and externally. And these are some of the outputs that come in the Global Water Tool. This is a real summary chart that rolls up the total amount of fresh water by the by energy chain value unit, seen on the left side for all value chain units, as well as individually for drilling, completion, production, gas processing, refinery, petrochemicals. It adds up the total water withdrawals, total water recycled, reused, and percent recycled, reused. There's a number of metrics. There's metrics than you probably want in the Global Water Tool, but we slice and dice all the numbers, every direction, to anticipate all the different metrics that companies might want to look at. A couple of messages that you can see on this slide by doing this analysis are, number one, refining uses greatest amount of fresh water compared to all of the other value chain units. So this issue of water management should really be on top for refining, and for drilling and completion, not so much. They don't use very much water, really only 20% of the whole portfolio of the company. The other aspect is if right now for this company, most of the water withdrawals, 107 million cubic meter, compared to 115 total, are fresh water. So they're quite reliant on fresh water. Another takeaway message from this is that they should consider looking at lower quality
joining the conference,
perhaps seawater or municipal effluent or other sources of water to try to get away from the conference of fresh water that they're using. And the other interesting aspect is percentage of water recycled and reused. Even though they don't use too much fresh water, they're recycling a lot of it. So it's an interesting area to dig deeper and see what their cycle methods are and what they've been doing to have this number be so high. This slide is really the key takeaways from using the Global Water Tool. This is where you go through the effort of filling out the inventory of your sites and your water use. This slide shows one of the sum up worksheets that's in the tool. Once you've done your inventory and then connected to the World Business Council website and downloaded the watershed data, and it does it again automatically, really quickly actually, you'll be able to do this sort of analysis where you can compare your sites and the amount of fresh water you use at each site with these external stress severity factors. And we see in this chart that we had 4 sites that had annual less than 500 cubic meters per year. That's the most stressed condition by renewable water supply per person metric in that middle column. And looking out to 2025, that way. In case you're wondering, why did that one projection get to be a little bit less in Britain? It's a population factor looking out to 2025, and so it's based on a per person capita, and that's how the projections work. But what you see in this is that there's 5 sites with the red stars next to them that are in water-stressed areas. A variety of these by these external stress severity factors that have fairly high freshwater usages. So these are the sites that we looked at and said, okay, they use the most fresh water and they have the greatest external stress. So these are sites that we know we need to look at in a more deep fashion to make sure that we're managing our impacts and risks well, see if there's action that we should reasonably take to improve the situation. This shows one of the reporting sheets that's in the tool. And once you put through the effort and entered your site information and your facility metrics, a lot of wonderful reporting metrics are created. And we've done them all exactly to the requirements of the different kinds of reporting groups. They all have slightly different definitions, but we've been very careful in pulling the data together to report out to the dashes for each one. The spreadsheet you see here is for the IPIECA reporting metrics. We also have a sheet for Global Reporting Initiative and the new oil and gas sector that's come out. Those indicators are covered well. The definitions and calculations methods that we've included in the sheet meet the oil and gas sector standards, so that's great. Dow Jones Sustainability Index, and even CDP water metrics, including some of the more difficult questions there about water sources and water names and so on. The tool creates automatic output for those if you've done your inventory back at the beginning. It also creates bar chart distributions, such as shown here. What you see on the left-hand side is for all of the oil and gas value chain operations for Universe Energy. There's a distribution of sites in watersheds as shown. 20 of our sites were in abundant areas. 3 were in extreme scarcity, 5 were in scarcity, 3 were in stress, and 2 were in sufficient water supply. And then our biodiversity hotspot results shown on the right. 4 of our sites were in biodiversity hotspot areas, and we knew that we needed to take a look at how we were managing water because it is so important to ecosystem stress. So these distributions, again, help a company focus in on the sites that have the greatest external stress so that they know where to look in terms of making deeper dive assessments. Shows another way of looking at it, which is, again, the beauty of this tool is that there's outputs. Some of them are standardized like the ones you saw before, but it's an open code Excel source Excel code, so you can actually do some additional manipulations if you like and slice and dice things a different way and make other connections, and that's something I did here. I looked at the areas of water scarcity defined by these external stress factors, and then I added up how much fresh water was used in each one of these categories. And the good news is almost all of our fresh water is used in abundant areas. That made me feel better as being a responsible water manager for Universe Energy, but we did have 10 million cubic meters per year of fresh water used in areas of scarcity. And these are areas that we really need to go take further look at, and that's what we did next. You've done this global portfolio assessment with the Global Water Tool and reported metrics and looked at your data and made sure it's good, and then done the portfolio analysis around risks. The local next step then is to go do site risk management and site risk assessments around individual sites. When we created the Global Water Tool back in 2007, a lot of companies started using it. More than 300 companies have used it. It's been downloaded by 40,000 times, a lot of times. But the question we started getting in the last couple of years was, well, after we've done this portfolio risk assessment, the guidance for doing a local assessment at these high-risk sites. A year ago, we pulled together a group of 40 companies, and we worked with GEMI, which is a business organization, to create the local water tool that can work with the Global Water Tool as a next step. And the reason for doing this, the reason for using a local water tool is to do the site risk management for the reasons shown on this slide. Again, we had two kinds of reasons for wanting to do this for Universe Energy. First of all was external communication. We had stakeholders in some of these communities that were high stress asking us questions about what our impacts were and what our management plans were. So we knew we needed to do strategic messaging of our impacts and risks and management plans with stakeholders in these areas. And then for internal purposes, is we really wanted to make sure that our management plans were strong and robust in these areas where we had external stress and freshwater use. And also, we were planning a new project in Queensland, Australia, and we wanted to see what would be the best management plan for our effluent discharge. We had a couple different effluent discharge options to look at, and we wanted to use the local water tool to help assess that. And I'll discuss now. So, as I mentioned, we created...
Go into that, I really want to take a moment here, and one of the outcomes of the global water tool is you can see by the graphs, the tables, and the metrics output, a tremendous amount of ability to communicate a lot of information about your portfolio sites and to look at a deeper drill. And that's an incredible value that comes out of the global water tool. It is important when you do this, you'll learn as you do it. Data may or may not be in great shape, and that's one of the things that this tool allows you to begin to look at, is not only where am I stressed, but it also allows you to begin to look at inside your company, where can I make improvements to my processes so I can better understand some of the risks.
That's right. And the global water tool is really flexible enough to be used by companies that are just starting the journey in terms of managing water, or also for companies that have been managing water well for many years, but need a credible, consistent way to show the portfolio analysis and add up metrics and show progress and improvement both internally and externally. So now we talk about the use of the local water tool. And as I mentioned, this is a tool that's come together in the last year with more than 40 companies operating on it, and we've done it through GEMI, which is a general business organization in the U.S., and much like IPIECA, but it has members across multi-sectors. We created a general local water tool that works with the general global tool, but we also created a customized local water tool just for oil and gas with a group of about 17 oil companies that were part of this process. And it works with the global water tool for oil and gas, and it syncs together. The local water tool is actually going to have a public launch on the 6th of March, next Tuesday, and there's going to be a webinar, a public webinar that will be given. If you go to the GEMI website, you could probably find the place to register for that. It's going to be through the 2 Degrees Network webinar system. And it will also be a recorded and saved there for future use. But now I'm going to show you some outputs of using this tool, which again will just be available to the public free of charge in just a couple days. In this slide, you see what the output of the global water tool is. This is the portfolio output that a company gets once they've done the full assessment of entering all their sites. And an example shown, we had one site with red external stress and one with orange and 2 with yellow, and we decided we need to go and do a site assessment on those sites to see what our true impacts and risks are and see if they're managing them well. And the really good news here for those of you who need to manage water and use these tools are that we've made the 2 tools able to synchronize literally with the punch of one button. So if you've done the hard work of putting your information into the global water tool, you can transfer that over into individual spreadsheets in the local water tool very easily, and you won't have to retype information or anything. The local water tool operates on the same premise as the global water tool. You go to the GEMI website and you download an Excel tool, and you get to use it on the privacy of your own computers, and none of your data is saved or stored or shared with anyone else but yourselves. And it's also an Excel-based tool that's just downloadable. There's how to use it PowerPoint and some other information on the website to educate you about how to use it, and you can get going. So again, we've created the local water tool to synchronize with the global water tool for oil and gas to ease this transition into more deep site assessments. And this, I hope, doesn't scare anybody, but this is a key module in the local water tool, which is an assessment of the local external conditions, because the only way you can know your impacts and your stress on the external environment is to know what the external conditions are. And so working with these 45 companies, we went through and identified all the potential stresses, impacts and risks that a company might find at a given site. And we categorized them into 6 main categories of physical source characteristics, physical supply reliability, ecosystems, regulatory, economics, and social context. And then within those, individual risks were defined. And they were defined at specific levels of 0, of no risk at all, to 3, and a high risk. And inside the local water tool, it would be really useful if you downloaded it and looked at the definitions page, because it actually was about a 4-month effort with 45 companies and with the review of the external advisory group of NGOs during Stockholm World Water Week last year, that we came up with a common definition and assessment of what a high stress or a low stress, what a high risk, what a low risk is for each one of these things. And that's really the value of using this tool, because once you use a standardized tool with standardized language that really essentially the world agrees to, you can go through and do a local site assessment in one place, find what your impacts and what your risks are, and then be able to compare that to a completely different place, right? And until now, until there was this standard approach and standard framework with definitions, there wasn't one way to do that. Slide shows the overview of all the issues that are addressed in the local water tool, and it's quite comprehensive and really gives a good standardized output for looking at management of these issues. So imagine that we've gone through and used the local water tool, and that's really like waving a magic wand there that, boom, we've just done it. But if you'd like to learn more about using the tool, you can be a part of that next webinar, or in a lawn meeting of IPIECA. Actually, we're going to be having a local water tool session, and for those of you who are World Business Council members, we're also going to be having a local water tool session in Montreux in April. But imagine that we've used this tool for a refinery. And for this particular refinery, it's an arid area, a dry area here in California, and it's got closed-loop cooling. And we've already reduced the water usage at this refinery, but it still faced risks. The refinery knew that it had risks of scarcity and increasing industrialization in the area, so they went through the whole local water tool process, and the 3 specific high risks that they found, and find some low risks that were manageable, but the high risks that they found were that local ecosystems were under stress in the area, the other large users. Okay, now this particular usage wasn't the cause of it, but other users were causing ecosystem stresses in the area, which ends up being a stress for this refinery. Unfortunately, that's just the name of the game in water stress. You may not be causing a stress, but if someone in your watershed is and water is in a stress condition, it ends up being a risk to your facility. They also found that cumulative demand in the area would soon exceed local supply. And not surprisingly, there was increasing community public concern on the refinery's water use. Even though this refinery had been there for quite a while, had gone to closed-loop cooling, was minimizing water use, it still felt scrutiny from the public and these external risks. So after using the local water tool and seeing these specific issues that they had to deal with, not that just water was a problem, but exactly what the specific issues were, they were able to address each risk. And so they created a management plan that, number one, created an external communication with stakeholders on water efficiency, held stakeholder meetings to show the stakeholders that they were actually a small user in the area and that they had done a lot to reduce water usage, and that they were an employer of many jobs and provided economic benefits, but really they met with key stakeholders to show them the local perspective of water and who the main users were, and the fact that they were actually water efficient. And then, looking ahead that the situation may not getting any better, they also investigated the use of recycled municipal effluent as an alternative to fresh water, and they looked at the cost of hybrid dry cooling. Now, they decided not to make those investments or switch today, but they did the preliminary feasibility design in order to have those options ready should the water situation get towards a threshold where they knew that they would face restrictions. So those are discrete outcomes that can come from using the local water tool. And this example is one company used the local water tool for a new coal seam gas project that they were planning in Australia. So Queensland, Australia has a wonderful resource of coal seam gas, and as a byproduct of producing gas, there's also produced water that comes from each well, and in this case, they were planning to serve 10 cubic meters per day. So the Universal Energy Company wanted to employ the local water tool to look at their options for discharging the produced water. There were three main options that they knew they could evaluate. Build a pipeline of about 150 kilometers to the Pacific Ocean, discharging the coal seam gas water to the local stream, which is a small stream that dries up many times of the year, and it's called the Dargle Stream, or they could re-inject it to a disposal well. So those are the three options that knew they had, and they did a cost analysis of it, how much each one of those would cost, and it was in the same ballpark for each one. But they knew they had to do a risk and impact analysis to see what were the potential risks of using these options. So they used the local water tool to do that. And the tool guided them through was for each one of these options to look at these external stress severity issues. Like for the Dargle stream that you see in this picture, they looked at the capacity of that stream. Well, it's actually a problem because the capacity of that stream was very low. So that means it's a high risk for the oil company to discharge there because it would exceed the normal flow patterns of the stream and so on and really cause a disruption to local ecosystems and so on. So for each of those three options, the tool automatically set up these matrices that you see here and guided the company through the analysis of what the risks and impacts are. And magic, here's the outcome. This is a dashboard that is the automatic outcome of the tool. And I will say there's some cool technology in the way this Excel tool was made. There's some automatic pivot functions, and it's not as simple to use as the global water tool, but it gives really valuable output in a really comprehensive and credible way that you wouldn't get with any other kind of analysis. There's lots of instructions within the tool about how to use it and how to enter information so that all the pivoting functions and everything work well. So this is the output from the project planning exercise of using the local water tool. Up in the left-hand corner, you see a summary of the impacts, the potential impacts that were addressed or identified for the different discharges. And on the Pacific Ocean option, there was definitely an external impact potential for impact on local ecosystems because the charge of the point would be at a popular surfing beach that has a very precious ecosystem, and even though the water was relatively clean and wasn't too saline and so on, it was different ocean water. And anytime you have a difference in quality, it's going to have an impact on the local ecosystem. Even if you're discharging colder water or cleaner water, it will have an impact, and that would be a risk. So that even if anything else ever happened to that ecosystem, the finger could be pointed to them that they caused it. The Dargle stream had a lot of potential impacts on the receiving water body, both on the capacity, as I mentioned earlier, because the stream usually isn't that large, and on the quality. Again, if the discharge is at all different than what's normally in a water body, there's just a potential impact on quality and on ecosystems. So the analysis showed that the Pacific Ocean had one potentially large impact and the Dargle stream had three. Now on the risk side, which is the risks that the company feels from the external environment, the Pacific Ocean had 6 risks. around local ecosystems, regulatory risks that the company would face in terms of trying to get this discharge permitted, local reputation and social activism, just the idea that some stakeholders just wouldn't want any discharge into the ocean. Those are potential risks. And then as you can see, the Dargle stream discharge option had a lot of potential risks, all the way from capacity to agriculture and livestock demand patterns in the area, watershed ecosystems, discharge costs. It would be quite expensive to treat the water for this discharge. And then the disposal well only had a few potential risks in terms of costs of what it might cost to continue to re-inject. So after the company did this analysis and saw that the disposal well option had no impacts and the fewest potential risks, and it was on the same order of magnitude of cost as the other options, no surprise, they chose the disposal well option. This slide shows the last module that's in the local water tool helps the company identify its management plans for each one of these risks. So you actually use the tool to plan what the management method should be for the risks that the company is anticipating around reinjection. And the risks that they had were around delivered costs, meaning how much would it cost to reinject, and their management plan around that was to evaluate the most efficient reinjection pumps and look at operating scenarios to minimize costs. And then they know they also had risks around reputation and social activism, just as managing water out in this area, and local stakeholders would be interested. So they decided to prepare a presentation based on this analysis that they went through, actually, with the local water tool to show stakeholders that this option was actually the best for minimizing impacts to the environment and for avoiding risks and not having any problems, and that this is in the sense of the fact that it's a non-communicating reservoir that they were re-injecting to, and therefore this was the best management option they selected, and the stakeholders could understand why, and that risk went away. So this slide shows how when. Oh, go ahead.
A really important point here to attention to is, again, whether you have a new operation or an existing operation, this tool brings a consistent method to look at the risk, and the tool may do a couple of things. It may validate what you already thought was true. Now you've gone through the risk analysis and can demonstrate where the risks are and what the management or mitigation plans are. It may use some things that you thought were risks, but they turn out not to be, or they turn out not to be the largest risk to that project or an existing facility. Or it may identify new risks that you hadn't thought of altogether. And this tool allows you to, this combination of tools really allows you to look at that issue, bring it all the way down to this screen here where you've identified the risk, you put your management plans there, and you've done it all in a very consistent and methodical way.
Right. That really is a key outcome. For those of you on the phone, and Carl and myself who have all worked in water for so long, we hear, oh, there's risks. We have a risk around water. Well, that's such a big word, right? What is the risk? The point of this whole process, and especially the local water tool, is to help you get to the root of what the risk is. Is it a social risk? Is it that stakeholders don't understand? Is it a cost risk, that energy costs are really increasing and that your cost of your treatment is going to go up? Is it a physical supply risk that in the future, in the summer, due to climate change, you're not going to have precipitation and there's going to be droughts? What exactly is the risk? Because when you break it apart and get to that level and really identify what the risk is, which impact is, then a company can properly address it. And it's my belief that most companies are properly addressing these things right now, but the communication of properly addressing them probably hasn't been as robust as it could be because you haven't done this analysis to say what exactly our risk is and how we're managing it. And after you've done that for the local water tool, especially at high risk or controversial sites, you really have all the credible background you need to communicate internally, if you do need to make an investment, if it's wise to change to a different type of reuse, or to communicate externally and show stakeholders why what you're doing is the right thing, that your impact's actually minimal compared to others in the area, or to collaborate with others in the area and try to reduce the external stress in a collaborative way. This is a summary that really allows a company to determine if the management system is adequate, and then continue on in an ISO 14000 kind of thinking in terms of plan, do, check, act, and continue to look at what risks and impacts are in the future and make sure management methods are sufficient. So the idea of continuous improvement, again, the Global Water Tool, or Universal Oil Company, has done well in getting started in addressing their water management, but it's a long road. In the past year, we've collected data and measured portfolio-wide water performance. In high-risk areas, we've assessed impacts, risks, and sufficiency of management plans. We've used a local water tool to select the best option for effluent management at a new production site. And very importantly, we built credibility with internal and external stakeholders by using these consistent, credible tools and having hard metrics there around performance. But management is all about continuous improvement, and in 2012, Universe Energy plans to continue down this road of water management and begin by updating the Global Water Tool and Local Water Tool files compared to 2011 to look at trends if there are any. We also want to add quality data to the tools because the tools allow you to put in quality data, but we didn't have it at Universe Energy. And this is all a stepwise procedure. You can use all of these tools with the minimal amount of information, but the more information you have to put into them, the better results you get. So in 2012, that's going to be an addition that we, the Universe Energy Company, plan to. You remember the charts way back at the beginning where we had a lot of freshwater use and at a fair amount, 10 million cubic meters in water-stressed areas. We want to take a look at that and see if we can reduce that any further. And we did around this past year to looking at our use of non-fresh water in all of our operations. But that's something we want to do because it takes water to cool and to and also to promote oil recovery and make steam floods and so on. But we would take a better look at the ability to use non-fresh water to do those things. And then we are planning to survey recycle practices in existing operations and leverage those across assets. And all those plans require solid metrics, and both the Global Water Tool and Local Water Tool will be continually used in the future moving forward to help us achieve those goals. And this is just a slide of how we messaged the results of our efforts up to upper management in the past year. We looked across the world and where our operations were, and we conveyed to management the summary of our challenge, which is sourcing water, regulations, and the public perception around our water use. And then we summarized the actions that we were taking around water management through the use of these tools and promote recycle, reuse, and also use of lower quality water. So with that, I'd like to pass the phone back to Carl and encourage everybody, if you figure out how to use the webinar and you have a question, type it into the little box there on the bottom, and we have a little bit of time for questions. If not, you can always contact Ruth Rummer at IPIECA.org, and Ruth is based in the UK, and hopefully she's sound asleep right now, and we'll tell her that the webinar went well, that we were able to make it work, but you're always welcome to contact her with any follow-up questions. So back to you.
Great, Jan. This has given you a good overview of both the Global Water Tool for oil and gas and the Local Water Tool and how they can be used individually and together. This year, IPIECA has just rolled this tool out, and this next year, IPIECA is working on promoting the Global Water Tool for oil and gas as well as the Local Water Tool for oil and gas. The tool is both free and available on the IPIECA website, or after March 6th, the Local Water Tool will be available on the GEMI website. As for our promotion of the tools and the improvement across the industry as a whole, IPIECA has set an internal target. 80% of its members will utilize the tool by the end of the year. We're encouraging not only IPIECA members to use this, but non-IPIECA members and other organizations to utilize it. There's a tool workshop, as Jan pointed out earlier, on 19th of April in Milan, Italy. We went into both the global water tool and the local water tool for oil and gas in more depth, and we encourage you, if you're able to make plans to attend that. For attendance of that, please again contact Ruth Romer at IPIECA. Again, another chance for us to go with information about how the tool is used and share some lessons learned from some case studies that were early users in the industry, what they discovered as they went through this tool and the information. I want to look at the next steps in terms of what opportunities are there in water management and solutions. IPIECA currently is trying to work on developing upstream freshwater management guidance. There's some management guidance for the refining side done through IPIECA, and that's available online. But we're urging as many IPIECA members to have input into this, and of course encourage all participants in the oil and gas industry to feed information back to IPIECA so that we can improve the output for all to use. As I said, if you have questions, feel free to call or contact Ruth Romer at IPIECA.org. You can see her email address on the screen. I encourage you, if you do have questions, to please type those in at this time. The question that was offered during the presentation, and the question was asked, what are databases for the local tool? From this person's perspective, they said it seems that you would need strong, comprehensive, and credible benchmarking source data from local communities. And we start by answering that, and then Jan, you can feel free to offer additional comments, but absolutely correct. Databases for the local water tool are numerous. In fact, they're too numerous to have inside the tool. And for using the local water tool, you encourage to go out and find local data sets for their region, for their specific site, and to work with local entities in that area to get that information. A set of suggested sources, a starting point, if you would, that Jim will host on their website as a starting place to find some local data sources down by geography, but simply a starting place, and we really encourage users to go out and find additional data. Anything else to add to that?
Absolutely. That local assessment is really based on local, credible data, and we've created a big spreadsheet that's on the GEMI website to give suggestions by country where to go and look for information. But it's truly something that each site should look at in terms of what the best source of data is. All different issues that we have that range from social issues to cost issues to physical supply. We give some suggestions to get started, but it's really best for each individual site to see if they have a state or a province or a local community kind of database for each one of the issues.
Great, thank you. I'm here to see if any other questions come up here before we end this, and if nothing comes up, I do want to thank Jan for presenting today. I want to thank all of you for listening in, and I really encourage you to look at the tool, download it, and to begin to work with it for your organization, and have questions in your use or as you look through it to contact Ruth and seek input and help from that. I haven't seen any additional questions come up, so I'm going to close the discussion down here and allow individuals to go back to their mornings or their afternoons or their late evenings. I want to thank Jan and IPIECA for
leaving the conference.
This information, and I want to wish you all best of luck in using this. Thank you.
Bye.
Conference